really thrilled to have Lowell from Lowell's Fish Lab here. He has one of the absolute best YouTubes out there for information. He covers breeding like the severe mistacks and great coat cats. He has put a camera inside of an apistogramma cage so you can actually watch them spawn. He spends an incredible amount of time on that, and also, aside from the great photography and information on breeding, he also does some great work with 3D printing and has brought for us tonight one of his very carefully crafted breeding trays, which he can tell you more about. He actually brought 3. We have one in the auction for tonight, and then we're going to put one in the next month auction and one in the upcoming November big auction. So we kind of spread them out. I hit the button. But it's a fantastic tool.
Tell me how.
And anyway, without further ado, Lowell, give him a big round of applause to welcome to St. Louis and Maasai.
Come on, you're right. You pushed it already. There you go. Okay, sound check. Can you hear me okay? Wonderful. Get the PowerPoint. Yeah, fish. That's what we're here for, right? We're going to start with a black screen. I'll show you something in a minute. Okay, good evening. I want to start by saying thank you so much for having me. I've been looking forward to this for over a year now. This is an incredible club, a great group of people, and there's just so much talent and passion concentrated in this area. And it's a real pleasure to be here. I want to especially thank Steve and Andre, who have spent the better part of the last 2 days just giving me an incredible showing of what you guys have to offer. And I'm never going to forget this trip, so thank you so much for having me. And thank you for the introduction. My great love in the hobby is breeding fish. It's my favorite part. In a way, I feel like it's one of the ultimate expressions of the hobby, and I'm going to tell you why I love it so much. To me, it makes fish keeping, it changes it from creating an ornamental piece in your home to an active and goal-oriented pursuit that constantly refreshes itself as you work on new species. It's a perfect excuse to get more fish too, right? We all have collectoritis, we all want to get as many fish as we can. Well, getting into breeding is a great excuse to do that. You can exchange other species with hobbyists, it's fantastic. And of course, as you bring in all those other species, you need more tanks. We all have multiple tank syndrome, I assume. Well, again, perfect excuse for it. And if you participate in the BAP, the Breeders' Award programs, you get these cool awards. I don't know what you guys do here in this club, but at home we get cool framed placards that you can take home and hang up on the wall so you can explain to your house guests what a master breeder is and why someone gave you an award for it. Personally, I don't think when it comes to breeding, hobby is always the best word for it. The way I view it actually is a small-scale aquaculture. The methods, the equipment, and the creative problem solving, the puzzle solving that we have to do to figure out how to breed different species is the part that I enjoy the most. So this is what I do. I started this about 5 years ago. I have a small YouTube channel, and every time I breed a new species, I make a video trying to document the process, what I did to get the fish to breed and to raise the fry, their reproductive habits. It's a good time. You can kind of think of these like video spawning reports. So I guess because I do this, I think by the simplest definition that makes me a YouTuber, but I hope you won't hold that against me. I can assure you I care way more at being good at breeding the fish than about being successful at YouTube. But it does come with some advantages. A big part of what I do is recording the fish right as they're spawning, and so it's afforded me a chance to collect a large volume of some nice video of them doing that. And I'm going to show you as much as I can. So this is what I have in mind for you, my practical experience-based recommendations for breeding fish, general approaches. Fun story, by the way. When Steve first contacted me and invited me to come speak, I said yes, of course, because I would love the opportunity to come, meet this group especially, but speak about what? Because I don't really have a specialty. Right, I'm a club member myself. We have speakers, and I'm used to people coming in and speaking on a focus, a particular group of species. I don't have that kind of expertise. I tend to spread it out. And what he told me is, your unique approach to breeding is your specialty. Come talk about that, which I took to mean you do weird stuff. Come talk about it. So for better or worse, everything you're about to see, This is your talk. I think this is the 6th time I've given it, but this is your talk and you asked for it. Okay, what we're going to do, first we're going to cover some basic principles, kind of high level. This, I think, and I really hope would represent conventional wisdom about breeding. Then I'll show you some of the weird stuff that I do that other people may or may not. And then we'll finish with specific application. I'll show you how the first two would apply to a particular species or group of species. Now, normally what I do is I let the crowd vote on what species they want to hear about, but today it's a dictatorship. We had a special request way back when, so we're going to talk about one in particular. Okay, a few disclaimers before I get going. There's more than one way to get a job done, so if I show you a method that is different than how you do it or how you've seen it done, that doesn't mean I think anybody's wrong. It just means that there's more than one way to do it right. And this is based on observation, rarely science. Real science is hard, expensive, time-consuming. Right? I know I've got fish lab in the name, but if you're picturing white coats and clipboards, you got the wrong idea. What I do is only a lab like a meth lab is a lab. And last, I don't know what I don't know. Right? I bet you there's 200 to 250 cumulative years of breeding experience at least in this room, okay? And I have not had that much experience myself, so I have much to learn. And I think that if I were to get up and talk about all the same topics, if I gave all the same answers in another 5 years, that would be a failure on my part to keep learning. All right, let's get started. Number 1, species-only tanks. I think this can be especially challenging for people who are transitioning from what I think is a fantastic starting place these days, planted community tanks. They may get interested in breeding and be trying to figure out what they can breed in that space. And there are certainly things that you can accomplish, but I think it's generally a lot easier to, A, get the fish to breed, and also to be productive with that breeding when the fish are alone. Fish do prey on their own fry and on the fry of others, and in some cases they can even be reluctant to breed in the first place if they're surrounded by what they perceive as predators for their young. There are exceptions, though. Dithers. We usually talk about dithers in the context of drawing away aggression from aggressive species, maybe cichlids, right? But small, schooling fish, they can also add an atmosphere that makes other fish feel secure, because if there was a large predator around, those schooling fish would be the first to go, like a frightened flock of birds. So I'll show you an example. These are some Bolivian rams that are bred a few years ago. Very healthy, beautiful specimens, very flighty, very nervous. They didn't come out much into the open, and they just didn't seem right. And they certainly weren't breeding for me. So what I did, I added some tetras. These are emperor tetras right here, and just simply the presence of those emperor tetras in the made the fish immediately more outgoing, and within, I don't know, a few days or a week, they spawned for me. And they kept on spawning from that point onward. Okay, multiple tanks. Another thing, you will be a lot more productive if you're able to separate eggs and fry from the adults, and the only way to do that most of the time is with separate tanks or maybe some small breeding enclosures. But I think if you want to get into breeding seriously, you're going to need more than one tank. And also, personally, I think if you had to choose, you could have a lot more fun in this hobby with 4 10-gallons than you can with one 40-gallon. And it also allows you to have multiple projects going at the same time. You know, breeding often takes a lot of patience. When I bring in fish that I want to breed, it is often 18 months to 2 years later that I actually do it. It takes time, and if you find yourself, you know, we've all got the ADHD these days, right? So it helps to have multiple things going at the same time. Okay, water changes and filtration. I doubt you need to hear this, but you're definitely going to want to equip yourself to change water easily, because when breeding, you're going to have an unnaturally large density of fish in a small space, and you're going to be feeding them a lot of food. You're going to need to change water, and carrying buckets around sometimes just doesn't do it. I started that way. I went years relying on pythons, which are wonderful. If you're still doing buckets, look into pythons. They can be life-changing, and I really couldn't have maintained the tanks that I did without one. Lately this year, I've been converting to a partially automated water change system, including this here, that I have been calling the world's most expensive bucket. But pythons do a great job. I mostly use sponge filters. Most cases, they're easy to replicate. It's easy to split up air pressure and handle filtration on multiple tanks with sponge filters. You know, they're cheap and they don't require a lot of maintenance. Sometimes on tanks with heavier waste loads, think grow-out tanks, I might use power filtration like canisters, but in the vast majority, I use sponge filters. And another great thing about them is that they won't suck in fry, so they're fry safe. Okay. Next, species selection. Let's just say you're getting started, you're thinking about it, you're dabbling with breeding. Well, I would recommend seeking initially species at least that have been known to breed in captivity. It's very tempting when you first get started. I did the same thing. Autocynclists, for example, are pretty tricky to breed, and I don't know anybody that can do it on demand. It's very tempting to think, well, that's because I haven't tried yet, right? Go for something that's at least known to do it. So for example, reticulated hillstream loaches, they're a little uncommon and they can actually be pretty expensive in stores, but they breed readily, very easy. I would say that's a good choice for anybody to start with. Pretty much put males and female together and they'll do it. Autocynclists, bad choice. But start simple-ish, right? You don't want to aim for the bottom. At least you want to make sure that the things that you're breeding are in demand locally. And this is going to vary from region to region, but I'll give you some examples. In my area, things like albino cories, a lot of guppies and endlers, crebensis, convict cichlids, things like that. Very easy to breed, and they would be a great experience for someone who's getting started with breeding, but you're going to have a hard time offloading those fry. Sometimes those are the kind of fish you'd have to pay someone to take from you. And of course, try to pick something that's reasonably suited to your local water unless you're prepared and equipped to modify your water with maybe hardening agents. I don't have that problem. Reverse osmosis filters to soften the water. If you're not prepared to do that, or if you're not real lucky with having kind of middle of the road water, try to pick species that fit your water. Okay, now I wouldn't say avoid, but think carefully and have a plan if you're wanting to breed fish where only us hardcore fish hobbyists even know the existence of it. Also think about undesirable sexual dimorphism, things like killifish and rainbow fish. Some of those fish are among the most beautiful we have available to us. The problem is a lot of them have females that don't look so good. So if something goes wrong and you end up with a skewed sex ratio and too many females, sure, there's some appetite for having trios and pairs for other people who want to breed, but for the general consumer, you're going to have a hard time offloading the females. So again, don't avoid, but just think about it and make sure you have a plan for where those fry are going to go. For stock selection, you want to make sure you buy enough fish to ensure you have reasonable chances of getting male and female, especially if they're not easily sexable, but also to tolerate some losses. We do the best we can to keep our fish safe and healthy, but things happen, and especially when we first get the fish, when they've been in transit through the aquarium trade, right? That's when they're most vulnerable. And so you want to get a few more than you think you need, just so that if you lose one or two, you don't unfortunately lose your one male or your one female out of that group. Okay, for schooling and shoaling fish, this number keeps growing over time. 6 is a number that I heard a lot when I first got started. It's usually enough, but as time goes on and I've been burned by not getting the right kind of sex ratio, it just keeps growing and growing. So 6, 8, 10, 12, maybe even more. It's however many I can afford that wouldn't be financially irresponsible. If they're sexable, though, you can oftentimes get away with just maybe 2. And this is a little bit divisive. I'm just going to walk you through my thought process here. I think that even pair-spawning fish, the majority of them, aren't that picky. And another thing I heard early on was that it is recommended, if not necessary, to buy a large group and allow them to form their own pairs based on whatever their preferences for sexual selection are. We've got a real smart guy in my area, a professor who studies specifically the sexual selection preferences of convict cichlids. We know it's a factor, but if you present 2 fish as the only options to partner up and breed, vast majority of the time they'll take it. And I think that, thank you very much. And I think that oftentimes what we're accomplishing when we buy a group is not so much helping the fish to find their soulmate because they have strict criteria, but rather to diffuse aggression while a pair that might as well be arbitrary eventually forms. And if you can manage that aggression in some other way, you can often get away with just buying a pair. Okay, other considerations? Quality sources. You guys are in an incredible position because you have so many breeders in the area. I don't know about the stores personally, but buy them from hobbyists. Do research and find good retailers, online retailers, and get the best you can. Always want to quarantine. We're probably tired of hearing about quarantining at this point, right, in our experience, but it's very important, I think, in a breeding context because you're not just talking about bringing in a few more tetras and maybe getting your display tank sick. You are going to have crazy volumes of fish in your possession, and if you have a disease breakout that spreads around, you're jeopardizing so many fish at the same time that you have to be especially careful about quarantining new fish. In general, I think if you can find tank-raised specimens of the fish, you're going to have an easier time convincing them to breed than if they're wild-caught. Though I will say, if you do acquire wild-caught specimens and they breed, it feels extra rewarding. It's a lot of fun. Really feels like you've done a good job making them happy, but if your goal is just to get the job done, tank raised is going to be easier. And of course, allow time for them to mature. Okay. I would recommend getting into culturing live foods. Now, this was actually a bit of a tough sell to me when I first got started, especially brine shrimp for some reason. Because the way it was described, it sounded like a daily commitment, which it can be, but it doesn't have to be because brine shrimp are there and you make them when you need them. The live food cultures that I actually struggle with are the ones that you have to maintain constantly or they go away forever. So for example, microworms. I don't particularly enjoy that because I need them twice a year and I wake up in a cold sweat some night going, I gotta put new potatoes in my microworm culture or they'll be dead when I need them. I don't like those so much. Live foods seem like a lot of extra work, but it's trivial work. I like to think of them as work leverage. It's adding frequent but trivial labor to reduce the difficulty, to trivialize the difficulty of raising fry when the time comes. Here I have some of the most common examples that we use in the hobby. I got brine shrimp here, microworms, vinegar eels, paramecium/infusoria. These, I think, are the most common, and in my opinion, you can get away with all but 2 of them. This is going to be very opinion-based. Some people love some of these, but I'm just going to make a case for if you could only pick 2, I think 2 of them would be best. Next, you want to pick an approach. Natural and artificial. Okay, for natural, think about the planted tank with substrate, hardscape, lots of plants. Artificial, think more like bare bottom enclosures, breeding boxes and things like that. That often gets called artificial and sometimes, to me at least pejoratively, has been called sterile. Okay, and I don't think either one of those, natural or artificial, is a particularly accurate way to describe our choices. Because aquariums aren't natural, right? It's a glass box of water in our houses where the substrate, the hardscape, the plants, the animals, the microbial populations, the water, they could all be from different continents. There's nothing natural about that. All aquariums are artificial, and none of them are sterile. You could take the cleanest, what appears to be the cleanest tank you think you have, and if you examine it at the microscopic level, you find that it's anything but sterile. Okay, so it's a bit wordy, but I think a better description of our choices is a spectrum of ecological complexity, high versus low. And each has, I think, advantages and disadvantages. So higher ecological complexity. The tank is full of attractive places to spawn. That's great. Natural food sources, especially if you have plants, you're going to be bringing in a diverse starter population of many small organisms that collectively we would call infusoria, everything from ciliates to microcrustaceans, and that can grow in population and provide a built-in food supply for some amount of fry. It's also lower relative effort. If you just put fish in a nice planted tank and you feed them well, sometimes fry just pop up, survive predation, and arrive eventually at adulthood. And it didn't take much particular effort from you. It just happened, and that's awesome. Emperor tetras always come to mind. Those little guys just find a way to soldier on, and they just keep popping up. There are disadvantages, though. In that complex of an environment, it's harder to tell what's going on. It's harder to keep tabs of what the fish are doing, how are their relationships doing, where are they spawned, did they spawn, are there fry, are they hiding, what's there? And that natural food supply that can grow in the tank, How can you control or predict the volume and the availability of that food for fry? If you have fry that are born in a planted tank, now chances are there's going to be enough food in there that some number of them will stay fed and grow, but can it feed 100? How can you know and how can you predict? You also end up with fry of mixed sizes, especially if you have adult fish that are continuously spawning in that space. You could have some that are a week or 2 weeks older than the others. And when you have fry of mixed sizes, you end up getting dramatic out-competition for resources, for food, right? And you can end up with some that grow much faster, get much larger, and you can end up even stunting some of the smaller ones because they just can't keep up. It's always easier to raise fry in one space that are approximately the same size. And of course, you're going to lose plenty of eggs and fry to predation. It's harder to keep clean also. Like I mentioned, you're going to be feeding food in abnormal high volumes, right? And it's a little bit tricky to clean up after that when there's all these complex nooks and crannies for the food to fall into and go uneaten. And I think that in general, as fun as it is to watch, as beautiful as the space is to observe, and how convenient it can be to produce some fry in a more complex environment, I think it has a lower ceiling, maximum ceiling for productivity than a more artificial approach, a more controlled approach. Okay, lower complexity environments. Chief advantage, you have perfect awareness and visibility. If you set it up right, you can see just about everything, know exactly what the fish are doing. If you have eggs to collect, things like that. You have total control over food availability, which is a part of why I think it's so important to learn how to culture live foods, because you need to be able to provide them on demand in the right volume at the right time. And they're relatively clean. Again, they're not sterile, but a simpler environment is easy to clean up uneaten food and fish waste. Okay, easy to maintain. And I think that, if you're into it, a more controlled approach is where you're going to have the highest maximum potential for productivity. And it's just cool, right? I'm going to start showing my bias here if I haven't already, but I like the gadgets involved in an artificial approach to breeding. I'm going to show you some. There are disadvantages, though. Everything that you gain control over, you also gain total responsibility for. So if you're not feeding the fry, they're not eating. A complex technological setup for housing and raising fry. If a power cord becomes unplugged or an airline, you could wake up in the morning and find that your fry have all been lost to ammonia poisoning. So it takes more effort, I think, to maintain, and also there's a lower margin for error. Okay, next up, you want to know the method of reproduction, at least generally speaking. Bear tanks are usually not ideal. Maybe some live bearers are a bit of an exception, but most fish are going to require some physical structure in the tank to facilitate their reproduction. And knowing how they reproduce can help you to set up the tank properly to do that. So I'm going to show you a few simple examples from some species that I've bred. For example, open spawning egg layers. That would include many cichlids and some others, sure. These are some rams, for example. They like to spawn on top of objects that are above the substrate. They'll clean them and lay their eggs there. We've got a clay pot here. That's the Dean Tweedale special. Co-op easy planters are like ram magnets when they're spawning, actually. Smooth river rocks. Stiff leaves sometimes. Yeah, just to show you how not picky they are. There's a couple of rams spawning on a submersible filter. At this point, I think rams are so domesticated that if you put your hand down on the bottom of the tank and held still long enough, they'd probably spawn on the back of your hand. And here's what that looks like. Here's a female laying some eggs in a row, forming a cluster. Here's a larger male coming back behind to fertilize those eggs. Beautiful to see in person. Okay, others like the Bolivian rams, they'll spawn much the same way on raised platforms, but they also tend to dig pits and either lay their eggs at the bottom, as you see there, or let their fry hatch into wigglers and then move them into the pit later. Angelfish are known to spawn on cones, slates, maybe even stiff plant leaves like Amazon swords. And Corydoras I would actually also place in the egg layer category, because I think of egg layers as being a case where the fish choose a spot specifically to place their eggs and come back there to place more. I'll show you what that looks like. Here are some Scleromistax barbatus returning to this patch that they're creating of eggs. She's got some in her fins there, so she'll place them. And here she's going to drop a couple. Yeah, it happens. Okay. Yeah, again, oftentimes stiff plants, especially cories, they seem to love the undersides of anubias leaves or sometimes crypts, especially if they're in water flow. Okay, cave spawning egg layers, lots of dwarf cichlids, shell dwellers, which I would loosely lump in special cave, plecos, we know. I'll show you some examples. A pair of apistos, the female will lead the male inside. She'll lay her eggs on the ceiling or the wall, and that little twitch the male just did there is flinging milk in the direction of those eggs. Crebensis, very similar in how they go about this. The only difference is the males seem to make much closer contact with the eggs when fertilizing, and personally I think that lends to a better fertilization rate. Okay, here's some shell dwellers. They have an interesting strategy. So they can't both fit inside this shell, so the female will lead the male to it. The male will sit in the opening, release milk, and as the female backs out, the water displacement pulls the milk deep inside where it can reach the eggs. Okay, mop spawners. I would place killifish in that category. These would be adhesive eggs that the fish go and stick on some kind of, I imagine it's something akin to marginal vegetation. I think spawning mops simulate that pretty well. Rice fish, another great example. Here's some killies. Doing a little shimmy, eggs and milk happening. That egg is stuck on her underside there, but she'll go brush it off on the mop. Okay, I would also place Corydoras actually in the mop spawning category. I know I just put them in egg layer, but they spawn in mops pretty much. They do the same thing. They'll line up side by side and do a little shimmy. Fire out the eggs like a confetti popper, and Gary, you were just telling me about this. There's the other females just waiting to eat the, yeah, their aim was a little off. Okay. Egg scatterers, I place these in kind of a couple different categories based on how you set things up for them. There's some with adhesive eggs and some with non-adhesive eggs. I don't know very many that aren't attracted to plants directly, so things like danios and barbs. Danios, these happen to be CPDs. They are so magnetically attracted to bushy vegetation. You can easily construct what we would call an egg trap, something to collect the eggs on the underside as the eggs fall down from within the vegetation. There's them doing their thing. And you can go retrieve those eggs later, carefully dodging the fish poop. Here's a different approach. Instead of using an egg trap, you could do the vegetation over kind of coarse gravel, which will have the eggs settle down within and be harder for the adults to find and eat. There you go, fire out some eggs, and you'll see very productive. The ground is just littered with eggs and fry. I think you're going to see, yeah, one spawn, ridiculously prolific. There's another category of egg scatterers with adhesive eggs. I just happened to figure this out while trying to breed some pencilfish. I was finding eggs stuck on the undersides of things. They don't want to go high. They don't want to spawn in hanging mops or anything. They want to stay low near the substrate, but their eggs are sticky, and they as they fling around, they tend to stick to the undersides of things. And this is nigh on blasphemy. I apologize, I just have to show you this video, it's cool. Sometimes rainbow fish do it too. If all they have available to them is an attractive spawning site near the substrate, they'll do it too, and I'll show you. This is me replicating something I just happened to see. This is a tank where I thought, they're not gonna spawn, and I was okay with that. There was a little half-dead ball of Java moss in there, maybe the size of a golf ball. I mean, brown, it was so dead. And I saw them do this and then set it up again just to see if it was a fluke. Different fish too. Here's the shimmy. There you go, everywhere. I don't know what to call that, but scattering. Next, you want to try to create the right atmosphere, right? Minimize stress and maximize feelings of comfort and security in their space. So, as much as I like to keep things simple, they can benefit from plants, from hardscapes, from shelters, especially overhead, so that they don't feel like they're sitting under open sky where a bird might swoop down and get them. And more aggressive species, especially like cichlids, can benefit from having line of sight breaks, things to kind of partition the tank apart so they don't fight with each other. And lower lighting, this is not perfectly generalizable, but I tend to believe that many fish are more comfortable in lower light, again, because they don't feel like they're under open sky where they're at threat of being picked off by a bird. And regions of calm water is another big one for me. Again, not perfectly generalizable, but I think that many fish are going to preferentially seek out areas to lay their eggs where the water current will not be overwhelming and sweep them away and destroy them after they've been deposited. Next, you want to learn spawning triggers. Okay, number one, I think the most important, is an increase in food volume and quantity. Really good foods, and I think live foods, right? I saw big bags of blackworms being passed around. That's just fantastic. And water changes. I think this is another one of the most universal. Now, we talk about water changes as being a pronounced trigger, especially with a little temperature drop for Corydoras, but I don't think I've ever dealt with a species that didn't get a little bit more interested in breeding after a good water change. Now, there's a long and diverse list of environmental shifts that can also induce other species to breed, but they're a little beyond this presentation. Another trigger, if you can call it that, is restricting opportunities to spawn. So I have had great success with keeping males and females together that have some general interest in breeding, and using some kind of a divider that is permeable or translucent where they can see each other and they're in the same water if there's a hormonal influence, but they can't actually physically reach each other and spawn. And then, once you see that built up interest, struggling to get through the divider and get to each other, right, you can pull it, and you can sometimes encourage them to breed where they wouldn't have before, or you can just time and choose when you want the breeding to happen so that you can better coordinate collection and preservation of eggs, for example, or separating them afterwards if there's post-spawn aggression. Okay, on to the weird stuff. Number one for me, keep your friends close. Now, this is a bit of an extreme example. As you see, I love filming fish, and so I don't think many people are actually going to do this, but I have long USB cables and webcams set up on many different tanks. I stream them to my computer, so while I'm sitting and working, I can keep an eye on what's happening. That's how I know to run over with a camera sometimes and start filming if I can't physically see the tank. But in general, and this I think is broadly applicable, if you are anxiously engaged in a breeding project, I think you'd be well served by keeping that tank somewhere where you spend a lot of time. Because when you spend time with the tank, your chances of catching important benchmarks in the breeding process are going to be greatly improved. And also keep an eye if your fish are getting mean with each other. But yeah, knowing when the fish are spawning can help you act at times to maximize productivity. For example, here are some gold ocellatus shell dwellers. And I often heard these talked about in the context of colony breeding, where the numbers would gradually increase, which means some fry can survive in the space, but they do try to eat their fry. I'll show you an example. Watch down here in a second. See that? That was the dad. He escaped, by the way, don't worry. Okay, so when you see the shell dwellers, the female sitting in a shell like that, flapping the fins around, odds are she's got eggs in there or she's got fry. What if you just pull every other fish in the tank? Let them dart into their shells, put them in another suitable tank. The female immediately relaxes. She lets the fry out, spread around, very easy to feed that way, and productivity can be very high. That's what I chose to do. You may not do that. My point is, if I wasn't there to see that behavior, I wouldn't have known it's time to take action and change the setup. Okay, obviously I favor lower ecological complexity, but not exactly bare bottom. This actually is a good example of about as complex as most of my tanks get. Layer of fine sand. Sand is wonderful. It's not always the best for growing plants, but I think if you had to pick one substrate that was really well suited for the most fish, fine sand is good. I like these planters because they allow me to hold plants like broadleaf Danubius you see here to provide overhead cover without needing a bunch of substrate. And the sand is also easy to siphon off debris, uneaten food, and fish waste. I am a big believer of concentrating fry into a small space. They're easier to feed when they're in a small space. It's a small area to keep clean and remove their waste, and you have great visibility. You can keep an eye on their size, their growth rate, their shape, their color, which correlates closely at times with health, right? You can see if one's getting sick or has died, and you can remove it. We're going to talk about that a little bit more later. But as much benefit as I see in keeping fry contained, there is a point of diminished return. Now, this is going to vary species by species, Some are very fast growing, some are very slow growing, but if I was going to throw out a number applicable to species that aren't exceptionally slow growers, it seems to be somewhere around 3 or 4 weeks. I don't know exactly why. There's a lot of theories, and I'm not sure. But within the first couple of weeks, I think, is where you get the most benefit from keeping them contained. Then it steeply declines and actually crosses over to the point where their growth rate will diminish, and they can even be stunted if you don't release them into a larger space. Okay, essential live foods. Number one for me is baby brine shrimp. I think if you could pick only one, this is the single most valuable. It handles many, if not most, scenarios as a first food or a second food for small fry. It's effective well into late juvenile phases and even adults for some smaller fish, or heck, when I have extra, I even feed them to my angelfish, and they still love them. The only problem with them is size. Sometimes they're not quite small enough. So I got a calibration slide from my microscope and tried to take some measurements here. So here's brine shrimp right about hatched. They're 540 microns is what I measured. That's about 0.5 millimeter. This is a common strain. And if you want to go smaller, there is another strain, a San Francisco strain, where they hatch out. I measured them about 475 microns. Not as much smaller as I thought they were, but about 12 to 20%. And a brine shrimp right at hatch is vastly different from one a day later or 2 days later. This is about 48 hours of that smaller San Francisco strain. It's now 850 microns. And so if you're able to feed them when they're freshly hatched, they're a lot smaller, a lot easier for small fry to handle. Okay, but they grow quickly, and you can use temperature, how you apply temperature to the hatchery to help extend their usefulness after they've hatched. A couple of things that I consider to be myths or misconceptions about brine shrimp. I want to advocate for their use, obviously. I often heard that brine shrimp are nutritionally worthless some number of hours after they hatch, and I think it's very fair to say that they are worth less as they grow. They're consuming, they're unconsumed nutrient stores, right? But they're not worthless. If they were worthless, none of my fish would grow, because most of the brine shrimp I feed are 40 to 48 hours from hatch time. Okay, so it is very common to apply heat to a hatchery, whether it's an incandescent light aimed at it to both warm it up and to have the brine shrimp attract to the bottom. These ZIS hatcheries are even built for you to put an electric heater in the top and keep it warm. That's great, and that can get you a hatch a lot faster. You can even get them at 16 to 18 hours if you're up at 80 degrees. Above 82, it's too hot and doesn't quite go so well. But what I've taken to doing is an unheated hatch, cold or room temperature. For me, that's about 72 degrees, and I go on a 2-day cycle. So if I were home tonight, I would be starting a batch of brine shrimp that I would feed 2 nights from then, starting at maybe 44 hours from that point. And they're ready right about when you need them, 2 days later. And without that heat still applied, their degradation is much slower. And you can even go into a 3rd day sometimes before they really start breaking down. Another one is that the unhatched shells of brine shrimp kill fry. While that is not impossible, I believe that it has happened. I haven't seen it happen that I can identify, and really what I see more often is that the fry just eat around it. Even Corydoras, which you think are dumb and indiscriminate, if you have brine shrimp and some eggs on the bottom, they just eat around them, and what's left are a few little brown dots. They just pick them up and they spit them out like it's a rock. I think it's obvious to them most of the time that it's not food. You know, the hatched brine shrimp, they taste good, they smell good, they're moving around, and the eggs don't. I do think there is some danger in brine shrimp, and that's in gorging. I think we feed them to fry that are used to eating very small amounts, bit by bit, all throughout the day, and they're not accustomed to having this flood of available food all at once, and their job is to eat everything they can get their mouth on. So you give them too much, they will eat too much. And I think that especially for dwarf cichlid fry, for example, that I've dealt with, that can be hard on their digestive tract and cause them issues if they overeat brine shrimp. For some reason, things like tetras, danios, they can completely deform themselves. They eat so many brine shrimp, it doesn't seem to bother them as much. Anyway, something you want to use restraint on. So again, brine shrimp sometimes are not quite small enough. Sometimes we have to go even smaller. And my next most favored food are paramecium. This is Paramecium caudatum, which is a common one to culture. This one measured in, this is about where they top out, 270 microns, so half the length of the brine shrimp, but quite a bit narrower. And I find that for many fish, this handles needs prior to brine shrimp if they can't start with brine shrimp right away. Here's some examples. Here are some rams. You can see they're large, they're easy to see, easy to hunt down, they move. Great first food. They're especially useful for fish that don't hunt them down, kind of ambush predators, that wait until something comes in front of their face before they snap at it. I choose to culture Paramecium specifically in isolation rather than trying to create a broad infusoria culture. One approach is take some water out of your aquarium, put it in a container, and let something rot in that water. Well, that's going to provide food for bacteria. Bacteria will feed ciliates, and you can have a bloom of small infusorians that will feed fry. But it's hard to, again, to predict and control. And one thing people have trouble with is knowing whether that culture actually has organisms so small that they can't see them, or if it's just cloudy, putrid water. And a nice thing I like about Paramecium is that they're visible to the naked eye without magnification. And it's very easy to tell what the density is of the organisms in that culture, so you know that you're giving your fry something that they're going to be able to eat. Very easy to culture. You can walk away from these things if you set them up right for 2, maybe 3 months without giving them a new food source. Very sustainable. I've had the same cultures for years. Big fan. Okay, what about the nematodes? They are conspicuously missing from my list of favorites. Well, they're small diameter, but they're very long. For example, vinegar eels here. I measured them at 1900. They reportedly range from 1 to 2 microns, so that's 1 to 2 millimeters. Microworms, they say on the internet they can top out at 3, but I couldn't find any larger than 1600 microns. Banana worms are very similar to microworms, but they top out a little bit smaller. And personally, you're only feeding a nematode when the fry need exceptionally small food. I don't know why you'd ever want microworms over banana worms. The smaller, the better. Bite-sized portions are easier. Now, Andre, we were talking about this last night. In the microworm cultures, it's not always the adults that the fry are eating. It can be the babies. Most of the time, I've pulled samples and checked them out. It wasn't until very recently, because I went looking, that I found the babies. Someone tell me if this is true. I've heard that the babies live more in the culture and the adults crawl up the walls. Yeah, close enough to true? Where do we harvest our microworms from? Usually the walls, right? Yeah. There's nothing wrong with this. Nematodes are great. They're soft. They can be a great food source. They're just not usually my choice. I get away with the other two. And they can be cumbersome for fry. Take, for example, this is a little Danio chopre on what will be its first day free swimming. It's about 4,600 microns end to end. Of that, I'd say approximately 675 microns are its head. And what portion of that is its actual mouth? I don't know. I couldn't measure. But just imagine a 675 micron head trying to choke down a 1,900 micron vinegar eel. That would be like us trying to eat a pool noodle. It's a little bit cumbersome. But again, they can do it. Here's some of those ram fry. There's a window of time for them in the first few days where vinegar eels can be very useful. But usually at that time, they can also take brine shrimp. Big, dense packets of nutrition. You feed them and they're good for a few hours, and so I tend to favor them. All right, what about the bottom feeders? Those might not be for quite so well. Paramecium float around. I was reading Ian Fuller's book, and he said he feeds Paramecium to the Corydorus fry. I can't picture that, but he can't be wrong. It must work. I'm going to try that. Well, a lot of times bottom feeders, I find, are more apt to eat dry foods that settle to the bottom. They're not quite as picky. Brine shrimp, they tend to move around in the water, away from where the bottom feeders would get them, but they will settle to the bottom eventually. And one thing I like to do, if you've ever killed the air supply to your hatchery, you might notice if you go too long before coming back and draining them, they've all settled to the bottom. And if you're within, I want to say like an hour or two, they may look dead, but they're probably not dead. They're just hypoxic and they're not really moving. But if you put that air back on, remarkably, most of them will come back to life and start swimming around. So I'm going to say they're almost dead, but they're not dead yet. And you can manufacture that scenario if you want. You can harvest some and just let them sit in a dish for a bit, come back later. And they'll be so low on oxygen that if you place them on the bottom of an enclosure with the fry, they will generally stay there. They'll keep twitching, which will attract them to be eaten, but they won't really flow off into the water column and disperse. Okay, specialized equipment. This is one of my favorite parts. I think it's especially important for a lower complexity, more artificial, more controlled approach. I want to show a few specific things. I just want you to know I don't think you need exactly what I'm going to show you, but I do think you need things that accomplish the same purpose. So acquire them, source them, DIY them however you can. All right, here are some tools that I use for egg collection. I am big on 3D printing, and I have had so much fun designing my own equipment for use in breeding activities. Here we have an example of a simple egg trap right there with the screen. This is an automatic collector, and I use both of these at times to collect eggs, as opposed to that simple cup. This was just a convenient way for me to place a durable, permeable screen and collect eggs afterwards. That's about the most CPD eggs I've seen in one place. And that was one spawn, so they work very well for me. These automatic collectors have been very popular recently. The idea here, if you've never seen them, is that you have a roughly conical, basically a funnel with a hole at the bottom where an air uplift routes that tube up and into an enclosure that would collect the eggs. Acrylic breeding boxes work really well for that. I personally don't think that these are the best way to collect the maximum number of eggs. In fact, I don't think you should collect eggs daily from fish at all. I kind of like building them up, fattening them up, and then having a big spawning event so that I can get the most fry at one time so that I'm raising the most fry at the same size. It's a little bit more productive to me. What I do really love these for, and I think that they're just invaluable, almost irreplaceable for, is what I would call prospecting, which is to set these up on a tank of fish that are not as predictable as CPDs, for example. They lay eggs like chickens. They spawn every single day, but there's other species that are a little bit more sporadic with their spawns, and it gets really labor intensive to get your arm in the tank and pull and check traps every day. Well, when you set one of these up, you can just walk by, shine a flashlight at your acrylic breeding box, for example, and see whether eggs were collected. And then if you choose to set up a different way to collect more eggs, great, or you can just keep doing this. But I found them to be very useful. And I think we have some very bright minds in Australia to think for this concept. Just brilliant. Egg incubation. Clean enclosures with circulation, aeration goes a big way to protect eggs, to allow them to incubate safely without being overcome by fungal growth, which is kind of the chief risk to their health. Antifungal additives can be useful. Methylene blue is great. That's a tried and true solution, but there is some element of toxicity to them. I don't think enough that we typically notice, but there's something to it there, right? It only works because it kills small stuff. So there's something not quite great about it. Tannins work also very well. Alder cones are kind of my tannin source of choice. And fry enclosures. Just hold that thought. We'll talk about it more in detail in a minute. Okay, I use some special culture containers and also some live food auto feeders I'll show you here. Paramecium tend to concentrate near a food source. So what I did is I made myself a culture container out of a plant pot, drilled a hole in a plastic container lid there. And what I do is I put the food source, I like wheat berries, I put them in a little mesh, dunk them in there, put a foam cap on top to keep the bugs out. And what it tends to do is bring the densest population of paramecium near the top of the culture where they're easiest to extract with a pipette or a turkey baster to where you're getting the most paramecium and the least nasty culture water when you withdraw a sample. It's also very easy to just withdraw that mesh, put in a new food source, and keep going rather than having to dump it out and kind of restart the culture. Shortly after doing that, I started experimenting with using peristaltic pumps to auto-dose those paramecium. So what I did, I drilled 2 holes in it. I have one line drawing the culture water into the pump and dispensing them for the fry. It's coming out of a tube here. And then I have a return line bringing fresh, clean water back into the culture container so that the water level doesn't drop below the food source or the intake line. And this allows me to feed them as many times per day as I want. All I do is watch the culture density, and when it starts to thin out, I swap it for another culture container. I also, even more recently, started doing this with brine shrimp. It's a little more complicated, but I swear I'm not crazy. It's not as bad as it looks. We have another peristaltic pump here, only a single pump. There's no return line. Here I have a bottle of brine shrimp. These are fresh water. They've already been sieved and rinsed, and that's fresh water. And this is actually a refrigerator. When they're refrigerated, they stay fresh much longer. They can stay alive even in fresh water as long as there's a little aeration keeping them moving for 2, almost 3 days in fresh water. I was really surprised by that, but it works well. This has allowed me to travel more safely and continue feeding brine shrimp while I'm gone. It's also helped me, even when I'm home, to feed 15, 16, 17 times a day in small amounts, and I have seen incredible growth rates from being able to feed my favorite food as often as I want, even at night. And I actually want to try and show it to you. We'll see if this works. What's the projector seeing? Is it on a particular display?
No.
It's not seeing my screen.
You need to back out if I put in escape to
Okay.
back out of PowerPoint.
Yeah, you're probably right. There we go. Okay. So this is live from home. There's 40 leopard frog plecos in there, if you can believe it.
They're in Sacramento, California.
And with the press of the button on the phone, you'll see a little drip, a little splash up there. Sorry. And they should notice in a second and start moving towards it. That is mounted on a tube that actually delivers them, the brine shrimp, to the floor level so they don't wash away in the water as much. It brings them to the floor, then they spread out, and for bottom feeders it works really well. All right, we won't wait for them. Are they going?
They're being fed on the top up there?
Yeah.
This is your return on the bottom right side?
This is the insert line. Anyway, fun stuff. Great for travel. Okay.
How much are you feeding at one time?
I wouldn't even know where to begin measuring as much as they can eat. Okay, and we're back. Okay, fry enclosures. These are a very important part of the process for me. And here's kind of where I started. Very small tank. This was early on for me. I had some Cory fry in there. It's not this particular instance. Those are much bigger than I'm talking about, but a couple of days old. And I noticed that when I was feeding them, the food would kind of spread out around the tank. And they didn't venture out from their safe spaces, hiding under a piece of wood or clump of moss and go find that food. And early on, I had some unfortunate mortality just because they didn't seem to be able to find when I was feeding them. So one of the things I tried first was housing the fry in these simple Fluval, Marina, whoever owns them now, these acrylic breeding boxes. Those can get the job done if you modify them right, but they do have some downsides. They're not really purpose-built for it. Next thing I used were German breeding rings, which are excellent, air-driven, permeable bottom, which is awesome, fry can't escape from them. Those are great. But I had some very specific needs, and I decided to try to make my own, right? And I have some background with design and with 3D printing, so I thought, let me see if I can print one. This is an example of what I ended up making. You've been seeing pictures of it the whole time. This is a breeding box, fry tray, whatever you want to call it. It is an enclosure to house fry with a air uplift driven inlet of water with these dampening structures that help take that turbulent flow of bubbly water and reconsolidate it into a smooth flow, more like it's being pumped electrically. Being gentle on fry is very important to me, especially for some of the smaller, more sensitive ones. It has a fry-safe outflow here, blocked by pieces of foam cut to the right size. You can choose different porosities based on what kind of fry you're dealing with, what kind of food they're eating. And I also use mounts for rigid tubing to supply supplemental aeration. It helps to keep biofilm protein film rather, from developing on the surface. It also helps to break surface tension. If you're feeding a fry powder dusting on the surface, it helps it to fall down. Yes, Gary?
Do you have an overflow on that in case it's sponge?
Here and here. Just to the left and just to the right of the sponge, so they don't go over and into the sponge, because they'd never make it out. And if this looks familiar in arrangement, in format, Dean Tweedo was gracious enough to test these for me when I was first making them, and he gave me some great feedback and made major contributions, especially to the outflow style. So thank you to him. They may also grant wishes, we're not sure. Can't confirm. Here's an example of one in use with some rams. This is what I made it for. I made it for rams. And they have been very helpful to me. Okay, early feeding strategies. For me, those depend on primarily where the fry like to spend their time. Think about bottom feeders, mid-column, or surface feeders. Not only where they spend their time, but also the shape, the morphology of the fry themselves. Some have mouths oriented towards the bottom, like Corydoras fry. Those are probably going to take their food off the bottom. Some are more flexible, forward-oriented. They may either only want to feed out of the mid-water column, but again, this is a tetra, for example. They're actually pretty flexible about where they take their food, but that forward orientation is a good indicator. This, I don't know if you can see in great detail, but the lower lip, if you want to call it that, protrudes farther. It's got an upward turned mouth, and that might suggest that it wants to take food from above it, so it might be a surface feeder. For the bottom feeders, I will often not start with brine shrimp, but like I said, maybe start with a dry food. Fry powders mixed with water so that instead of sitting on the surface, they just sink straight to the bottom. Ceramicron I like because it's fine, but it's a little bit more chunky than others, and it tends to settle quickly. And I'll mix that up and then dispense it with a pipette on the bottom. Baby brine shrimp as a next food works great. For mid-column feeding, my preferred is paramecium, right? Usually right off the bat. You can feed it with a turkey baster or a pipette. You can auto-dose it, like I showed you if you're a lunatic. Or you can just get a good dense sample from the culture and dump it in the tank. It'll swirl around everywhere, and that works fine too. I also use fry powder mixed with water, but this time finer. Think golden pearls to 5 to 50 micron. New Life Spectrum's Grow fry powder is also very fine, and you can kind of spurt it out into the mid-column and it'll swirl around, and even those forward-feeding fry can have an easier time grabbing the particles out of the water. And a little bit of gentle bubbling kind of near the bottom of an enclosure can help to keep those particulates circulating throughout the water column for them. And of course, brine shrimp. For surface feeding, again, paramecium, they're just a winner pretty much for any scenario, but very well for surface feeders too. Fry powder, this is one of the easiest ways to use fry powder, is when you can just dust it on the surface of the water and the fry come and eat it off the top. If you have them in a space with some bubbling, with rising bubbles, those can also help to break surface tension as they hit the surface, and then the particulates will rain down, and some of the fry that aren't strong enough to break surface tension on their own can then grab them out of the water column. You sensing a theme here? More brine shrimp. Maybe some vinegar eels if you're into it. Okay, specific application, and then we're out of here. We're going to talk about rams. Okay, in my experience, and these are German blue rams, in my experience, if you can get the parents to raise the fry themselves in the tank and you don't have to separate them, it's just any other cichlid. It's very easy, and they do a great job of parenting when they choose to. I have even seen an adult ram grab a mouthful of brine shrimp, swim back to the school of fry, and spit them at the... It's incredible to see. Sometimes they don't want to do that, though. Sometimes they're not cooperative. Maybe they fight, maybe they eat the eggs, they're just not good parents. Sometimes you have to raise them artificially, and that's what I want to focus on because it's the more challenging approach to raising them. It's very helpful to know when they spawn, and for me, they always spawn in the last few hours before the lights go out. After they finish their spawn, which can take anywhere from a half hour to a couple hours, it depends on how well they're coming out of the female, yoink those eggs, move them to a clean container. Clean water is very helpful at the same temperature, which for me is, I usually do like 82 to 84 degrees. with some aeration to help keep debris from accumulating on the eggs themselves and also keep the oxygen level up in that warm water. I typically use methylene blue here to prevent fungus. And pretty quickly, within the first 12 to 24 hours, you'll see the infertile ones that would normally be white, they will absorb that blue stain, and you can see how many are still alive. So it's a challenge. Like I mentioned, methylene blue is mildly toxic to some degree. So typically, after eggs hatch in methylene blue, we change out that blue water and replace it with fresh. But that can be a little agitating and maybe rough on the freshly hatched wigglers. So what I picked up on doing, and I really like, is waiting for the eye spots to show on they're not eyes, but you know what I mean, little dark patches to show. On rams, this is only in the last X many hours right before they hatch, and so as soon as you see those eye spots, you could just pick up the whole thing they spawned on and put it in clean water, and there you go. There goes the methylene blue. If you're using a clay saucer, it tends to soak the blue in, and it might leach back out, but okay, do it a second time. So right after they break free from their eggs, they'll kind of wiggle around. That's why we call them wigglers. And some of them, if they have a hard time breaking loose, this is why, if you saw it, it's very helpful if the thing that the eggs are on is vertical rather than laying face down. Is if it's vertical, as they shake loose, they can more easily separate from it, get away from the wreckage of their egg that will fungus pretty quickly. And if you see one kind of struggling to do that, you can take a pipette and gently puff water on it, and it'll help to knock them down. And here's what that looks like. Here's our wigglers. Yeah. And there they go. That's them falling for the first time off the plate. They do this for a few days. They tend to clump together because they're still adhesive. On the top of their heads, there's a little adhesive patch. And from there, at around 82 to 84 degrees, it tends to take about 3 days until they're free swimming. And I try to not move them until then. They're very small and fragile. I just leave them alone until they rise up into the water column on their own. From there, I put them into a safe enclosure, like one of those trays I showed you. And even though they've started free swimming already, I usually don't try to feed right away. A lot of time, they start free swimming on a morning, and it won't be until later that night that I feed them for the first time. All right, so here's the problem with baby rams. Because they're challenging. Here's the trick. The problem with baby rams is that they're stupid. They're meant to have their parents there to keep them corralled in and guide them and keep them safe, and they're really not equipped to survive without them, so they can get themselves in a lot of trouble. Okay, without the parents in the same space, the rams are primarily attracted to each other, like so. Next to light. This may just be a me thing, but I think that if you have really intense lighting over a container of rams, I think you can kill them with it, because they will spend all day worshiping the sun, irresistibly attracted to it, rather than dispersing into the space and finding food like they're supposed to. They will sit there all day long, and they can't go very long without eating. So I like to keep the lighting a bit subdued. Their attraction to light can be used to your advantage, though. I'll show you in a minute. Last thing, water flow. If you have some water current that might be damaging to them, they love to just go right into it, take a tumble. This is a great tip that I learned from Dean Tweedale. We were talking on the phone one time. He shared this with me. I was like, I've never seen you talk about this before. It's a great idea. You can use a focused gooseneck lamp to place a spotlight and allow you to choose where in the enclosure you want the fry to congregate. Here's examples how well this works. Again, irresistibly attracted to that light. And it can also draw in the brine shrimp, as you know, right? They're attracted to light, brings the shrimp to the fry. It's awesome. The other reason I think, there could be many reasons people have a hard time with raising ram fry, but I think in general, one thing that tunes up the difficulty is they're in super hot water, and there may be an argument that you don't need to be to raise them as hot as we do. They do grow faster in warm water, but in that hot water, they've got a fast metabolism, they're burning calories, they're moving around, and I just think they need really frequent feedings to keep up with that. That's a struggle to do, when you've got busy lives to keep up with. And here's some things you can do to help overcome that. For one, if you aren't there to feed them, suppose you feed them in the morning and then you have to go to work, turn the light off. They'll go to bed. They'll clump up on the bottom and just relax. They won't burn so many calories and they won't need as much food if you have to be gone for many hours at a time. Come home, turn the lights back on, and feed them again. And yeah, just frequent feedings and giving them the right kinds of food. So examples, we've already kind of seen here. Paramecium do a great job. I never raised rams with the auto feeder. I got to try that. They can take fry powder right off the surface, but I don't think they're built for taking stuff off the surface. So what I like to do, again, mix it up in a pipette, inject it into the water column and let it flow around. I think they have a little bit easier time picking the particulates out of the water. Somewhere in first 2 or 3 days, you've got a few days of window where vinegar eels can be appropriate if you want to use them. And then, of course, brine shrimp. Look at this little guy. He's trying to take it from the pipette. Okay, here they are a couple of weeks later, much larger and stronger. And from here, you're done. There's really not much more to it after this. Okay, let them get to an appropriate size. Again, their growth will slow. Like this right here, I wouldn't push too much farther past that. You want to release them into a larger space. But really, once you've gotten them to this size, you're out of the danger zone and you pretty much got it in the bag, just like any other fish. Okay? That's it. That's all I got. Any questions before I wrap up here? Yes.
So I got some black convicts, and they spawned right away, and I wasn't expecting it at all, and I'm a little worried to do water changes without like sucking them up or whatever.
How big of a tank?
It's 20. Yeah.
Okay. Well, if I were in your shoes, I would be siphoning out the water on one side with them on the other and kind of shooing them, scaring them away from it.
Okay.
I think you can pull that off without picking them up. And if you go into a bucket maybe, or a large bin instead of into a sink or something with a python, if you do happen to grab one, you can retrieve it later.
Okay.
Some people also put fine screens like pantyhose and whatnot over the tube they're using to siphon. A python is wider and works well with that, yeah. Anybody else? Oh, I think you were next. Yeah, go ahead, please.
There's a question online that asks about what's your experience regarding keeping eggs and wigglers in darkness versus light?
No preference. But when they're illuminated, for me, they're not in bright lighting, so I'm not sure I'm giving the right answer. Maybe really bright light is not good for them. I wouldn't know, but I don't keep them in darkness deliberately. Yes?
So starter culture for paramecium?
Say again?
Do you need a starter culture to start paramecium?
I'm sorry, do you need a starter? Well, no. Technically, you can find them in your aquarium, but you'll find other things too. And one of the things that's a little challenging about starting an infusoria culture or a paramecium culture from aquarium water is that along with the things you want to culture, which are primarily, we're talking about ciliates like paramecium, you'll also very likely bring in with them their predators like cyclops. And so you can have a bloom and then you come back a couple weeks later and there's just a few cyclops swimming around and your stuff is gone. So I source my starter cultures from a company here in the US called Carolina Biological Supply. It ends up being about $20 or so out the door with shipping, but they'll send you a clean, isolated culture of your chosen species of paramecium. Caudatum's a great one, multimicronucleatum is another large one, and they're easy to care for. Carolina Biological Supply. They got all kinds of starter cultures. That's a good point. If there's not 20 people in this room that have active paramecium cultures, I'd be shocked. Okay, any last questions?
Do you sell or do anything with your hatcheries?
I do. The print files are available. You can look me up on YouTube. There's links on there, Lowell's Fish Lab. You can get a hold of STLs if you have a printer and if you want to make them. And by demand, I started making them and selling them because a lot of people don't have printers. So if you want those, you can track them down. And just a reminder, there's one of them donated to the club auction for tonight if you want to take one home and try it. Okay, anything else? Yes.
What are your favorite ones to breed? Like, are there ones that you continuously go back and breed, or do you just breed one like fish for a while and then try something new?
I like to learn as much as I can. I like to shake it up, but I love Corydoras and I love dwarf cichlids, especially epistos.
All right, cool.
All right, let's wrap it up. Thank you so much.